Hello, students. So I've told you dictionaries are powerful, but what other things can we use them for? I mean, graph theory is a wonderful subject, but we can do so much with dictionaries. Really, we are ready to even start writing video games once we've introduced dictionaries. Like, how would we write a game that plays, I don't know, or at least, you know, that in some sense plays Go or checkers or maybe even tic-tac-toe. We have to store the state of the board as something. And just in the interest of time, with these short videos, let's work with tic-tac-toe. So let's say you have a tic-tac-toe board, and what we could do is we could say, hey, let's write down the row and column of each of the possible spots, right? So tic-tac-toe has a 3x3 board. So let's just write this out, 2, 0, 2, 1, and 2, 2. Boom, that's my tic-tac-toe board. So let's say X wants to go somewhere. I want to store the board after X has moved there. So in order to do that, what I could do is I could say, okay, board is going to be a dictionary, and what I'm going to do is I'm going to say spot 0, 0 goes to X. Now, I could store O as 0, just because O and 0 look similar, and X I can store as 1. We'll get to strings soon in this course, but let's do that for now, and then I can refer to my board and I can see, hey, this is a dictionary. It stores the contents of the board. Next, O is going to go over there, so now I want to add to it. Now, I don't want to just rewrite over this, so one thing I could do is I could say, okay, O just went in the spot in the middle, and I want to set that spot to 0, and now let's see. Hey, I've done that. Now next, X is going to retaliate by going over here. So now what I could do is I could say board with the key 2, 2, set the value of that to 1. And now I have my board over here. And now you see, well, you might know where I'm going next. And as exciting as it must be for you to watch me play tic-tac-toe all by myself over here, we're not going to complete the game. We are going to talk about something that happens in checkers that doesn't happen in tic-tac-toe, and that's that a piece can get removed. Right? In tic-tac-toe, we're just putting pieces down. So this sort of a technique is always going to be fine. But in checkers, we need to be able to remove a checker. Now, in tic-tac-toe, we can't remove once you've placed your X or O. But let's say I wanted to just remove this X over here. Let's say we're playing some variant where I could remove that. Well, what could I do? Well, there's a few things I could do. One thing is I could create a new board, right? I could write over the board in some way. I could even use a dictionary comprehension. I could say, hey, let's do I board I for I in board if I is not 0, 0. So let's try that, and that comprehension worked. It gave me a new board. I could always overwrite board if I wanted to. But what if I just want to keep mutating board? I want to just get rid of this. Is there a function or a method that'll just eliminate this without me resorting to writing, a comprehension here? The answer is yes. In order to do that, we have a command called pop. And what pop does is you give it the key and it returns the value, but it doesn't just return the value, it also removes that key and the value. That key value pair is now gone. So for another example, let's get rid of that O in the middle. And that was an O, and what does my board look like now? It looks like just that. So pop mutates the dictionary by grabbing that element, but also removing, it grabs the value for you and it returns the value, but it removes the key when it does it. So if you want to remove a key, that's one way that you can do that. Pop also works for lists. Let's say I have, I don't know, I'll just randomly hit some numbers. not the necessarily the most beautiful list I could have come up with, but let's say I want to pop out the element number 2 starting with 0, so that would be 374. So I want to get rid of that 4. What does it do? Well, it tells me what was in that location, just like it does with dictionaries, right? So the keys here, if you wanted to think of this as a dictionary, which it's not, but if you did, it would be 0, 1, 2, 3, 4, 5. So I'm asking it to get rid of key 2, and it returns the value associated with that key. And what did it do to the list? It now just shifted everything over because it had to, because lists always have to be in the form 0, 1, 2, 3, 4, 5, and so on for the indexing. So it did that as well. Now, one thing that I should note is this mutates the list or dictionary in place. What do we mean by that? Well, like we saw before, let's say D is just 1, 2, 3, 4, and I decide I'm going to let E be equal to D. So since D is mutable, now if I do anything that mutates D, that's also going to mutate E. Or if I do anything that mutates E, it's going to mutate D. So for example, let's say I pop out 1 from D. What's D and what's E? It did it to both. However, if I have D equal, let's do one more example. Let's do the same thing. D is 1, 2, 3, 4. You'll notice I can do the same thing to E. Let's pop 3 from E. What happened to E? But since D and E, let's see. Oh, I forgot to set E to D. So let's set E to D. See, E was still the E from up here, where if I got rid of the 3, there would be nothing left in E. But okay, so now I'm going to take this E, which is now set to this D, and I'm going to pop out 3. And what did it do to E? It got rid of it, but what did it do to D? It got rid of it as well. What if I then just do this? Well, now I'm not mutating D. I'm telling it that the variable name D should point to this completely different dictionary. And as you see, it did not change E. So dictionaries are mutable, and the same things that happen with assignment, where if you set a new variable name for something, it's going to keep track of the mutations in that new variable name as well as the old one. That same thing still happens. Okay. So what if we wanted to put something mutable in a dictionary? So could I have a dictionary, say, that sends 1 to its own dictionary? Sure. It allows me to do that. And I could take D of 1, and I could even take D of 1 of 1 and grab the values inside this little dictionary. That's fine. Okay, but what if I wanted something mutable for the values? And that's going to run into some trouble. So you'll see here, let's say I wanted a dictionary, I want the keys to be mutable. So let me put something mutable in place of the key. And that gives me an error because, as we saw before, like I said, hashability doesn't entirely coincide with mutability, but for the examples we're looking at here, so far it does. And it's basically telling me, hey, this is something that might change. And why might we not want stuff that changes in the keys? Values is fine, but why might we not want stuff that changes in the keys? Because let's say you have two things, A and B, that are keys, and suddenly B becomes A. Well, now my dictionary changed size, but B then changes again. Well, the problem is my dictionary already got less stuff, so what's Python supposed to do? I mean, we already removed B entirely from the dictionary. It doesn't make sense to even try to put mutable things in as keys. Just like we saw before for sets, it doesn't even make sense. So that gives you some idea of the behavior of dictionaries and some examples of dictionaries and mutability.